So what we want to look at now is why this is useful. And it comes for the idea of how we want to solve equations. And specifically quadratic equations, which come up a lot. I had a physics prof once that said that most of reality can be modeled as a quadratic equation. And what I'm going to try to do here is we'll make a quadratic equation. And so there's some number times x squared plus some number times x plus some constant equals 0. And these numbers will vary in sign, but they'll help us find what the possible solutions could be. Now, one of the things that we can always do is we'll force a to be greater than 0, or a to be positive. And we'll see that this won't change the answers we get. And what happens, let's say a is negative, we'll just make it negative x squared minus 3x minus 4 equals 0. To force this to be positive, I'm going to divide everything by a negative. Excuse me. My apologies. Oh, that's recorded for posterity. And so if I divide the first term by a negative, I get x squared. If I divide the second term by a negative, I get 3x. If I divide the third term by a negative, I get 4. And I divide 0 by a negative, I get the same thing back. And so these have the same solutions. And this lets us be consistent, and especially when we're doing things like the AC method. If we make sure A is always positive, it'll keep our factoring easier for us when we do this. And so when we slide these across, I tried to make sure that everything's positive to get the answers. But let's just talk about in the general case. I know I can list these as two binomial factors. And so I have ax plus b times, I'm going to make these capital so as not to confuse them with the ones up here. So ax plus b times cx plus d equals 0. Well, one of our properties of real numbers is 2 things times 0. One of these has to be 0 for this to work. And so I can say either a is equal to 0 or b is equal to 0. Well, I can use that over here to help me, because I can say either ax plus b is equal to 0 or cx plus d is equal to 0. And these two things are going to give me my solutions. And what this does by factoring 2 things equal to 0 and using the fact that one of them is equal to 0 or the other is I've changed something that had a power of 2 and I've turned it into something that's linear. But notice I get 2 of them. Quadratics in general have the possibility of having 0, 1, or 2 real solutions. And when it has one solution, we'll see, we'll say it has a multiplicity of 2. But that's something we'll explore in a little more details when we start graphing these. So let's look at what this does for us. So if I have x squared minus 2x equals 35. Well, that's not in the format I wanted. The format I want is ax squared plus bx plus c equals 0. So I want my right-hand side to be 0. So I want to subtract 35 from both sides. And 35 minus 35 is 0. This is now in quadratic form. And so it'd be nice if I had two factors here. So I noticed that my factors of negative 35. So negative 1 and 35. Negative 5 and 7. Negative 7 and 5. Negative 35 and 1. And I need the two that add up to negative 2, which are these two. And so I have x minus 7 times x plus 5 equals 0. But this says x minus 7 equals 0 and x plus 5 equals 0. Or x, add 7 to both sides, subtract 5 from both sides. And so now I have two solutions. We usually write two solutions as a solution set, and we'll write them from smallest to largest. And so my solution set is negative 5, 7. Well, let's check that. Let's plug that back into the original. So I'll start with the negative 5. So I'll substitute my answers in. Negative 5 squared minus 2 times negative 5 equals 35. Well, negative squared, negative times a negative is positive, so that's 25. Minus 2 times negative 5, or negative 10. So 25 minus a minus, that's plus. And so 35 equals 35. So that works. Now let's try the 7. 7 squared minus 2 times 7 equals 35, or 49 minus 14 equals 35, or 35 equals 35. And that works too. And so this technique is going to work for us. If we factor out, we're able to solve a quadratic equation. So let's look at another one here. 5x squared minus 33x plus 40 equals 0. Now this is already in my ax squared bx c form, and I'm going to find this by factoring. So I'm going to use the AC method. My AC is a positive 200. Now because my middle term is negative, I'm only going to take the negative factor. So negative 1 and negative 200, negative 2 and negative 100. 3 doesn't go in there, but 4 does. Negative 4 minus 50. Negative 5 minus, let's see, 5 goes 40. Does 6 go in there? No, 6 doesn't go in there. Does 7 go in there? No. Does 8? 8 goes into that. Yes. All right. Let's see. And so now I've got to start writing off on the side. Does 8 go into there? 8 goes in twice. 16, 4, 25. Right. And so negative 8, negative 25. And I could keep going, but I noticed right now that negative 8, negative 25 adds up to the middle term I want. So I'm going to swap these over, and I'm actually, because I know I'm factoring, I want to put the negative 25x there. Right? I want to replace the 33 with these two numbers. And then minus 8 plus 40 equals 0. I'm going to group, right, my AC method here, and I'm going to pull out a 5x. Whoops, I'm sorry, that's x squared, right? 5x squared, my bad. And that's going to leave me with x minus 5. And so here I want to pull out a negative 8. So negative 8, and that's going to leave me with an x minus 5. Right? Because a negative times negative is a positive. I'm reverse distributing. These are the same. So I cover them up. Right? And so 5x minus 8 equals 0. And x minus 5 equals 0. So I'll add 8 to both sides here, and I'll divide by 5. And so for in this one, x is equal to 8/5, and x is equal to 5. So my solution set is 8/5 and 5. Now if I plug these back into here, I will get 0. Let's try it. I think I might end up needing a calculator here. I'll start with 5, and I'll substitute 5, and 5's not too bad. 5 times 5 squared minus 33 times 5 plus 40 equals 0. Well, 5 times 5 squared is 125 minus, that's 5, carry my 1, that's 165 plus 40 equals 0. Well, 40 minus 165 gives me minus 125, minus 125, 125. Hey, that works. It's not bad. Let's do the hard one now. All right, 5 times 8/5 squared minus 33 times 8/5 plus 40 equals 0. Oh, well, let's see. 5 times 64/25, right? Because that squared over that squared. Minus, well, let's see, that's 4. Carry my 2, 264/5 plus 40 equals 0. Well, I'm going to use the fact that that's divisible by 5, so I'm going to get 64/5 minus 264/5 plus 40 equals 0. Well, notice the 64 is in there, so I'm going to get minus 200 over 5 plus 40 equals 0. But 5 divides into 200 minus 40 plus 40. Hey, that worked. And so our solution sets work for us. And so we have the ability to solve quadratic equations and get answers for numbers. And notice in a lot of cases we got 2 answers. And so what we're going to look at next is going to be something called the quadratic formula.